now let us do carboxylic acids. Okay, so with carboxylic acids, they have a functional group COOH, right? So this is called a carboxyl group. Okay, so a carboxyl group, its structural formula looks like this: C, and then you have that O there, and then OH, right? So a carboxyl group is essentially a combination of a hydroxyl group and a carbonyl group, but we haven't seen an organic compound that has a carbonyl group yet. We will deal with that later on, but there are other organic compounds which have a carbonyl group. So a carbonyl group is this one, right? And then it has that. So we are saying that a carboxyl group, which is the one for carboxylic acids, has, in essence, it's a combination of the carbonyl group plus the OH or hydroxyl group. So this then gives that. Okay, so that's what happens. So we're saying that this thing is that, and then this small part is that. So essentially that's what we're saying. All right, so again, the carboxyl group, which is COOH, is a combination of the carbonyl group, which is CO, and the hydroxyl group, which is OH. So we will later see organic compounds that mainly contain the carbonyl groups. For now, we are focusing on the carboxyl group, which is or are the carboxylic acids. Right, so an example of a carboxylic acid is or would be ethanoic acid, right? So we'll come back to that. And then the general formula is CnH2nO2, or you use this one, CnH2n plus 1, and then you put COOH there, which is our functional group, this one for carboxylic acids. All right, so that's what happens with the general formula. And then when it comes to the suffix, all carboxylic acid compounds end with the words or the suffix anoic acid. So this one is one of the easiest to name because you would really, if ever, find actually it doesn't move. The functional group doesn't move. This one, the COOH, it's always located on the last carbon atom. So you don't have to find its location and therefore introduce the number or the location of that functional group when you are finally naming your IUPAC name. So what I mean by that is, like I said, let's take an example of a compound. Let's take ethanoic acid as an example. So ethanoic acid would look like this. So remember, for all our organic compounds, the name of the parent chain is dependent on how many carbon atoms it has. So when I say ethanoic acid, you would notice that there's the prefix eth in my name. So that eth means it contains 2 carbon atoms, right? So we will have that's carbon atom number 2. So what we mean by the functional group never really changes position is because it will always be located on the last carbon atom like this. Then the other carbon atoms will have your hydrogen atoms to bond to. So this would be ethanoic acid. But don't worry, we will learn to name them later on in this video. So if you check this eth, which means the parent chain has 2 carbon atoms, and you can see that it has 1, 2 carbon atoms. And then there's your suffix here, the anoic acid, which is the suffix for carboxylic acids. Or if it had one carbon atom, it would be methanoic acid. You would have this, right? Okay, so you can see again, you have your suffix there, and then you have your prefix there. So this one, unless you have other substituents in the parent chain, for instance, unless you have a halogen there or an alkyl group, it's simply going to be the prefix and the suffix of the carboxylic acid. So what we mean by that, let's bring our table just to emphasize that point. All right, so here's our table. Remember, the number of carbon atoms dictates the stem name. So the stem name in this case would be the name of the parent chain, right? But here it's only the prefix, and then depending on the homologous series, then we can add a suffix to make up the full IUPAC name or the full name of the parent chain. So what we mean by that is, remember, this table is applicable to pretty much all the organic compounds that we've seen so far, and we're still going to do, right? What then changes is the last part, or the suffix, right? So in this case, where our homologous series is the carboxylic acids, right? So we take this and we say, well, if now I have a carboxylic acid that has one carbon atom in its parent chain, the stem name of that parent chain will be meth, but then the full name of the parent chain will include the suffix of the homologous series, which is anoic acid. So now it becomes methanoic acid. Same here, if it has 2 carbon atoms, the stem name is eth, but the full name of that chain, in this case the full name of the compound as well, would be ethanoic acid. So what happens is, if this carboxylic acid does not have any other substituents, it's just a chain that has the carboxyl group attached to it, then all these stem names will become the IUPAC name of that compound, right? Unless that compound has other substituents, then it might change. You might find that it's now 5-bromo-methanoic acid, or it's 2-chloroethanoic acid, or it's 2-methyl ethanoic acid, or whatever, right? It can be any combination. But for as long as there are no other substituents, we can use these parent chain names as the main IUPAC name of that compound, right? Because there's no other substituent to mention there in the final name. So this would be propanoic acid. This would be butanoic acid, right? I'm sure by now you get the idea, right? Until we get to decanoic acid. All right, so this is how the full table would look like. So for any carboxylic acid compound that we come across, the suffix is anoic acid, but of course the stem name will then depend on how many carbon atoms are in that main chain. All right, so we can actually call this a stem name plus suffix if we want, because that's what we just did there. All right, so now let us then focus on the rules that we have when it comes to naming these organic compounds, the carboxylic acids. All right, so these are the rules that we use when we're naming carboxylic acids. As you can see, there aren't many rules to talk about here, because if you've noticed that these rules carry over to the other organic compounds as well. Rules that we used when we were naming alkanes are found in alkenes, alkynes, haloalkanes, alcohols, and now carboxylic acids. And one of those rules happens to be finding the longest chain that contains the functional group, right? In this case, the functional group must contain a carboxyl group. Otherwise, the parent chain must contain a carboxyl group. Otherwise, it's not a parent chain, right? So, and then again, number 3, we number the substituents according to the positions and list them alphabetically in the final name. So we've seen this rule from alkanes until now, right? So that's just to show that the rules don't really change that much. So with enough practice, you won't really need to think that these rules are somehow isolated, right? If you know that first things first, I must find my longest carbon chain, my longest continuous carbon chain, and then it must contain the functional group of that specific homologous series, in this case a carboxyl group because we're dealing with carboxylic acids. And then I must prioritize a triple or a double bond if it's present, and then I must prioritize a functional group if it's present as well, depending on the organic compound that I'm dealing with, right? So, and then from there, I can then decide which side is it best to start numbering from. Is it from left to right or from right to left, right? So it's the same rules that are just repeating. It's just that what changes now is what suffix are we using, what is the functional group of that homologous series, and so on and so forth. All right, so in the case of carboxylic acid, it's still similar rules. All right, so now what we can do is let's go straight to examples. We've laid out pretty much the basics of carboxylic acids, and yeah, let's go ahead and start our examples. All right, so this is our first example. Now if you check here, the main chain is quite straightforward to see, right? Remember, it must always contain our carboxyl group. So this is our carboxyl group, right? And then the main chain includes that carbon atom of our carboxyl group, okay? So basically you do not exclude the carbon atom that is part of the carboxyl group. Okay, so it has to be included. So when you are counting your carbon atoms, you include that one. So in this case, we would have 1, 2, 3, 4, about 4 carbon, exactly 4 carbon atoms, all right, in the parent chain or in the main chain. As a result, that would have to be butanoic acid, if you remember from what we were doing here. So 4 is butanoic acid. So that's the name of our parent chain. So the stem name of our parent chain is but, and then the full name of our parent chain would be butanoic acid. Of course, in this case, the full name happens also to be the name of the compound, right? Because there are no other substituents here. We are only dealing with the carboxyl group. So let's go and fill our table. We'll say the number of carbon atoms in the parent chain, there are 4. The name is but. That's the stem name of the parent chain because there are 4 carbon atoms. Now location of the substituents, we don't have any other substituents except the carboxyl group, so I won't include that for now. Or we can just say it's number 1, the carboxyl group. And then the name of the substituent, it's only the carboxyl group. And then now we can do the IUPAC name. So since there are no other substituents, there's nothing else except the carboxyl group, this will simply be butanoic acid. Notice that we do not have to mention the location. In fact, let's not put it here as well to avoid confusion. We do not have to mention the location of our carboxyl group because it never moves. For any carboxylic acid, it will always be there. It will always be at the last carbon atom, right, on the parent chain, the last or the first, depending on which side you're looking at it from, right? Because if you're looking at it from this side, going that from left, right to left, you see that it's on the first carbon atom. However, if you are looking at it from left to right, you notice that it's on the last carbon atom. All right, nonetheless, we start numbering from this carboxyl group, or the carbon atom that contains the carboxyl group, right, in the case of carboxylic acids. Okay, so that's one thing. So it'll always be the first thing that you see on the main chain, the first substituent. So there's no need to mention where it is. We don't, there's no need to say 1-butanoic acid. That's incorrect. In fact, it's just butanoic acid. All right, now we come to this example. Let's find our longest chain again. If we check 1, 2, 3, 4, 5, 6. All right, notice that I include the carbon atom, or I include the carboxyl group, because if you check, our carboxyl group is simply this one, COOH. That's our carboxyl group. In fact, let's just highlight it. That's the most obvious thing with carboxylic acids, the carboxyl group. It's always just there in your face. All right, so now let us check our chain. So the straight part is 6 carbon atoms. Let's check for, if we start counting from here, it's 1, 2, 3, 4, 5, 6 still. So you know me, I always choose the most convenient route. So I'll choose the straight chain as my main chain. That's my parent chain. And then if you see, now that I've taken out my parent chain, I can see that there's a branch outside the main chain, or going outside the main chain, which happens to be my alkyl group. And since it has 1 carbon atom, this would be methyl. Now, where do we start numbering from? We start numbering from right going to the left, right? Here we don't change the numbering, we don't test which side is better, because the carboxyl group will always be located on the first or the last carbon atom, depending on which side you're looking at it from, but always it will be on the first when we are numbering. So that's 1, 2, 3, 4, 5. So our methyl group is on carbon atom number 5, and then 6. So we have 6 carbon atoms in the main chain. So just a note here, we always number from the carbon atom of the carboxyl group. All right, so now let's go ahead and fill our nice table. Number of carbon atoms in the parent chain is 6. Stem name of the parent chain, since 6, it means hex, right? That's our stem name. Remember, if we come here as our table, 6 is hex, or hexanoic acid in this case. All right, and now, what is the location of our substituents? So the only substituents that we have are the carboxyl group and the methyl group. Right, so we won't mention the location of the carboxyl group, it's always in the first carbon atom anyway. So we'll mention the methyl group, which is on carbon atom number 5. The name of these substituents, we have the carboxyl, and the methyl group. Okay, now let's get the IUPAC name. So in the IUPAC name, we will start with our methyl group and its location. So it's on carbon atom number 5, methyl. And then now we can mention the name of our parent chain, which happens to be hexanoic acid. That's it. So there's no other alternative to naming this one. It's just 5-methyl hexanoic acid. So remember here, we said if it didn't have any substituents, it was simply going to be hexanoic acid. But now that it has a methyl group substituent, it has to be 5-methyl hexanoic acid. We have to include the name of the other substituent in our final IUPAC name. So in total, it actually has 2 substituents. Substituent number 1 is the functional group of the compound, which is the carboxyl group. Substituent number 2 is the methyl group, which is just a branch from the parent chain or the main chain of our organic compound. Okay, so that's how it works. And then this is how we would name such an organic compound or such a carboxylic acid compound. Okay, so let's go to our other example. Again, we have to find the longest continuous chain that includes the carboxyl group. Let's go ahead and do that. If I start from left here, direction doesn't matter because I'll always start from this side anyway. So let's start there. 1, 2, 3, 4, 5, 6, 7. Okay, now what if I go 1, 2, 3, 4, 5, 6? I still get 7. So I will opt for the straight chain. Convenience, right? It's easy for me to see it. Of course, you can opt for the branched one. It won't change the naming whatsoever. It will still be the same thing. All right, so that's my main chain. Let me mark it. So now we can start numbering. Remember, we always start from the carboxyl group. So we have 1, 2, 3, 4, 5, 6, and then 7. So there are 7 carbon atoms in my parent or main chain. And then now I notice that we have about 3 substituents, including the hydroxyl, the carboxyl group or the carboxyl group. So now that's our substituent number 1, the carboxyl group. That's our substituent number 2, the chlorine atom. And then that's our substituent number 3. This is our alkyl group, and the name of this alkyl group, since it has 1 carbon atom, it's methyl. It's the methyl group. All right. Okay, so that's what we have currently. 7 carbon atoms in my parent chain, and then this organic compound has 3 substituents, namely the carboxyl group, chlorine, and also the methyl group. All right, so we can go ahead and fill our table now. And again, remember, we always name or number these things from the carboxyl group. It's not like the other organic compounds where we have to check, is there a double bond or a triple bond present so that we can prioritize it? No. Here it's just a simple number from the carboxyl group rule. Okay, so that's what we have. And then let's check our table. What is the number of carbon atoms in the parent chain? We have 7. And then the stem name has to be hept because we have 7. Remember that. Let's go to our table and check. So if you check here, there are 7 carbon atoms, and then it will be hept. Right, it will be hept. That's our stem name of the parent chain. If of course this carboxylic acid, if it didn't have the methyl group and the chlorine, it would simply be heptanoic acid, and that's it. But now it has chlorine and the methyl group, and we have to include those two in our IUPAC name. So the name will change to something a bit more interesting. So the location of the substituents, we have 2 and 6. 2 is for chlorine, right? And then 6 is for methyl group. And then the name of these substituents are chlorine, we have carboxyl group, chlorine, and the methyl group. And methyl group. Right, those are all our substituents. Now let's go to the IUPAC name. Okay, so remember now alphabetic order is important here. Chlorine comes before methyl in the IUPAC naming. Why? Because the letter C, which is the first letter of the word chlorine, comes before the letter M in the alphabet. Right, so let's do that. What's the location of chlorine? Is 2. So we can say 2 chloro. What's the location of the methyl group? Is 6 methyl. And then we can say the name is heptanoic acid.